Hi, I'm Rodney. My channel on YouTube is Prankstaman, and this is my first video ever for YouTube. Bear with me. So, for my first video, I'll be doing alternators, 10SI and 12SI alternators. I'll be showing you how to tear them down, the individual parts, how to test them, and how to put them back together. And for a second part, I'll be testing them on my APU, auxiliary power unit. It's a gasoline engine where I hook one of these alternators up to it and I could jump cars with it. Well, let's get started. First things first, let's look at the alternators. I'm right here, this is a 10SI, and on my left here, this is a 12SI. I've already had these alternators tore down to make it easier to do this video, so should move pretty quick. First thing you notice right off the bat are the fronts. Pretty much the 10SI has a steel fan. The 12SI has a plastic fan with a steel disc on the front. Both of these alternators are interchangeable on vehicles. They have the same wiring hookup, same pigtails, except for this one produces 27 to 63 amps. This alternator produces 78 amps to 94 amps. Right off the bat, when you see them, you know this is guaranteed 63 amps. This is guaranteed 78 amps. 94 amps is pretty common. It's usually on AC cars. 63 amps, same thing here on AC cars with carburetors. This is probably went up to about 78, and then this one took over. Needed higher amperage for vehicles with EFIs and electric carburetors for GM cars. Turn to the side. As you can see why they're interchangeable. Almost the same case. Same dimensions here and here. Same spacing for the pulleys. The housings are interchangeable. You could put this back onto this front onto this back. When you look at the back, you'll notice a few differences also. 10SIs have slots on the rectifier. The 12SI has bigger slots for better cooling. It has a bigger rectifier to handle bigger amperage. As I said before, same hookups. Battery terminal, terminal 1, terminal 2. Battery terminal 1, terminal 2. And OR, R, and F. In order to wire these up, you could wire them up as 2-wire or 3 wires. 3 wires would be OEM on the pigtail. 2-wire hookups, if you know how to do the wiring under the hood of the car, you can get away with the 2 wires. I'll show you that part. The next part would be tear down of the casings. Pretty much start with the back. 5/16 for the through bolts. Helps if you have the ratchet going the right way. Like I said before, I already had these apart to make this a little bit easier. I'll keep the parts separate so I can show you the difference. Okay, now 12SI. I got all through bolts out. Now to split these cases, the stator stays in the back. What you want to do is lay it on its side, and you take a hammer and you hit the front housing where the swing arm and the bracket hole is, and that separates it. When you get so far, you stop and you pull it out. You'll hear the brushes click. Well, if I had the brush pen pulled. Okay. Not going to hear the brush pins. Same thing here. Tapping on the housing this way on its side, these alternators have a problem of seizing together due to the dissimilar metals. The stator's steel and the housing's aluminum. They just corrode and they lock. Working back and forth eases them out evenly. You don't tear anything up. Okay, now you got the cases separated. The next step would be to tear down the front. When you tear down the front, it's a 15/16 nut on a rotor. But if you notice, there's an Allen key hex in the center of the rotor. You could put an Allen key there and a 15/16 wrench to bust the nut loose, but it's too hard. I usually just grab an impact and it comes right off. Grab the pulley, put the impact on the nut, you hit it and you stop, you hit it and you stop. The rotor's going to start spinning, the stopping, and then the starting up is when it's going to come loose. Okay, you got the nuts off. Lock washer. You always make sure you put the lock washer back on. You don't want the pulley coming loose, so it'll wear down the shaft and mess up your rotor if it comes loose. Pulleys, different sizes, made different ways. This is a billet aftermarket pulley, all solid, built-in spacer. This here is an OEM, basically stamped steel welded together. It's got a spacer made on the pulley. Some of these, the spacer is a separate part. You don't want to mix them up. Keep your spacing right. And 10 SI, the steel fan, the spacer. The 12 SI has a plastic fan with a bigger spacer. If you notice the spacers, the different sizes, you can't use the smaller spacer on the 12 SI fan because it would bring the fan in too close to the housing and it would start scraping. And if you use the big spacer on the steel fan, it would have it too far away from the housing. It's going to throw your belt alignment off. That's if you're putting it back on a car. So you don't want to mix them up. Next step would be to push the rotor out. If you have trouble pushing the rotor out, you could stick it in a housing of some kind to where it's supported on the outside. Then you would use a center punch and set it inside where the Allen key head is, and you would tap it out. That way you don't damage the threads. Or you can push it on the table. That's why it does that. Same thing here, just push it down on the table, it will come out. Now let's talk about the housings. The housings are interchangeable, but they have their subtle differences. One housing has SAE bolts and threads in it. This one has a mixture of SAE bolts and threads in it. I'll show you the difference. If you look on the back side, this is where the swing arm attaches to. The back side has a solid round part where the threads are. This would be an SAE thread, and an SAE bolt hole, which is 3/8. The 12SI has a ridge that coincides with the fan to make it an airtight clearance to where you get better airflow through the alternator. It is also indented more. This would be a metric housing. This is a metric hole, 10 millimeter. And metric thread, how you tell about the metric thread would be it's not round up here. You have two slots where the bolt hole is. You can get a picture of it. Two slots on the back side. That's how you tell it's a metric housing. Okay, the bearings in them. This is a bearing retainer where it takes a sealed bearing. This bearing retainer has a hump in it which takes an open bearing. You could take this bearing retainer off, put grease in the bearing to service it, and put the bearing retainer back on, and the bearing retainer seals on the rotor spacer to keep the grease inside. Okay. The next would be the rotors. Grab the camera and I'll show you the difference. Okay, on the right's the 10SI rotor, and on the left is the 12SI rotor. When you hold them side by side, you'll notice the spacing is the same, so they're interchangeable. This rotor has a built-on spacer. It will not come off. The 12SI rotor has a spacer that does come off. You want to keep track of this. When I was talking about the pulley, where the pulley has the spacers that are separate from the pulley, they're almost the same length as this spacer. You don't want to mix them up. It's messing with the spacing of the rotor, that when you put the pulley spacer on, the stator is not inside the alternator is deep, so it gets less magnetic saturation in the stator. So you don't want to mix these up. The longer spacer goes on the rotor. And then the next difference would be profile picture, the shape of the rotor. This has more metal. It's more of a box shape. This is more round shape by the edges. This has less steel. This has more steel. More steel means a better magnet. When you look at the wiring inside, the depth of the wiring determines if it's a low amp or if it's a high amp rotor. A high amp rotor would be the wiring coming all the way up to the top of this groove right here. When you look at this one, it's indented some. This would be a medium amp stator, or I'm sorry, a medium amp rotor. This would be like a 55 amp if you have the right stator to match it, and this would be a 94 amp rotor if you have the matching stator to go with it. So this would be a high amp rotor, and this is a medium amp 10SI rotor. next step would be to tear down the backs. 10 SI, 12 SI, set these out of the way. You want to make sure you don't dent the shaft on this side. That's what roller bearings roll on. You don't want to hum in. That was the back part of the rotor. I don't know if you got that. Moving the camera around a lot. Okay, through bolts are interchangeable. 10 SI through bolts, OEM style, are a little bit longer than a 12 SI. This alternator's been rebuilt. It's got 10 SI bolts in it. They're interchangeable. No big deal. Okay, we'll tear down the back now. Start with the back, you start with the rotor. I'm sorry, the stator. You start with the stator. This part's the stator. 3 nuts on studs hold the stator in. Kind of hard to do it with one hand. There we go. Okay, these are the 3 that I removed, and the stator should just come right out. The stator is locked in there due to corrosion. You could take a hammer to it. I'll show you how to do that right now. Basically, grab the stator, put your hand inside, hold the stator, and you want to hit it right here where the bolt hole is. Tap it, come right up. If you have to get real nasty with it, you can pound on it. It's a good spot to pound on it. If you smash in those holes, all you have to do is take a screwdriver and round them out, ream them out. Let's do the 12 SI. Again, if you have trouble getting the stator out, you tap it, go around the housing evenly. You hold the stator, not the housing, and you hit the housing. So now you got the stators out. Okay, right off the bat, when you look at the back housings, they're almost identical. The only difference would be the rectifiers. The rectifiers are sized due to their amperage. 63 amp rectifier is straight across. 12 SI is more rounded, more metal for more cooling, a lot more fins. This would be the diode trio. This little black square right here, it comes down into the brush holder. This is a pretty cheap one. It's pretty small. This is about a medium duty. The heavy duty ones are the orange ones. When I get it apart, I'll show you how to circuit test everything. To get everything apart, usually a 1/4 inch bolts that hold everything together with 7/16 nut for the positive post. So I'll put the camera down and take everything apart. Okay, I got all the screws loose. Now I'll show you all the individual parts and the differences in between them. Like I said before, the 10SI rectifier is straight across. It has one ground bolt, one positive stud bolt with the nut. Pull out positive stud. You notice it has a plastic insulator on it. A lot of times people tighten this nut down when they're tightening down the battery cable, and they have a tendency to over tighten it, which will spin this, which means you can't tighten down the positive cable anymore, and you might crack that insulator, which will short out the alternator. And if you have the battery hooked up, fry the wire. Okay, this has the same thing. Plastic insulator. Make sure that's in good condition. Okay, this rectifier had one negative bolt. This rectifier has two negative bolts, one on each side. Take them out. Capacitor wire, that's the positive side of the rectifier. Capacitor screws. Capacitors, you notice there's two different sizes. There's really no difference between the two. One doesn't work better than the other just because they're bigger. In 20 years of building these things, I've had one capacitor that was bad, and when it was bad, the thing lit off like a fucking fuse. Okay, now let's go to the brush holder and the regulator. The regulator is this part right here, the brush holder. The insulators, there are two insulators. This one is insulated, this one is insulated. The reason for that is how the rotor gets its magnetism. It's controlled by the regulator through the ground. This supplies power to the rotor, which is unmetered, goes through the rotor, magnetizes it, and when it comes back, it goes into the regulator. The regulator controls the ground of the rotor. This part right here is if the regulator goes bad, it won't fry the rotor. It'll fry this part instead. It saves the rotor, but the alternator will work without it. It's just if the regulator blows, it'll probably take the rotor with it. And if you notice on this alternator, it doesn't have one. Insulating screws, you want to look at the insulator, make sure there's no cracks. A lot of times the plastic likes to dry and start cracking. If the power finds its way to ground, the alternator just won't work. In good condition. Seems to be okay. It's a negative bolt. Negative bolt. This part here is the trio. This is what supplies power to the rotor. I'll show you how to circuit test that in a little while. Like I said before, I've already had these alternators apart, so the brushes are already set. You set the brushes by pushing them in, then push the brush in, then it's held in by this steel rod. The steel rod is just a paper clip bent straight to hold the brushes in. Throw those aside. Then the regulators come out. Even though this rectifier has 2 negative ground bolts and this one has 1, these parts are interchangeable. You can put this rectifier in this alternator, this rectifier in this alternator. To bolt it in, this regulator, you would just use this ground, and this rectifier you would just use this ground. Since there's no hole for this bolt to go in, you would just have an extra bolt. There would be no danger of overheating just because you got one bolt hooked up to it. Okay, let's take a better look at the rectifiers. These are the 3 studs for the stators. These straps, copper, go to the diodes, which are soldered to the bars. This is your negative bar, which is the top one. The one towards the center of the alternator is the positive bar. Same thing here, the straps go into the studs where the stator leads sit down on. This is the positive bar, this is the negative bar, and if you notice, you could take these rectifiers apart. There's little pins in them, plastic pins you would push out, and they would the metal part would slide off the plastic part, which has 3 diodes attached to them. You could see them on the back. When you look at the diodes on the back through the air holes, you're looking for melted solder, burnt carbon, which would be signs of a bad diode. Then the housings are pretty much taken apart. Capacitors, the alternator will work without them. The capacitor is in there to take care of radio frequencies. The car radio would pick them up. You would hear the alternator whining through the radio. When you put the capacitor in there, it takes care of the interference. It would quiet that noise down. If you're using the alternator for any other purpose, say like an APU, you really don't need to hook the capacitor back up because you don't have a radio to pick up the frequency. Pretty much it for the backs. Next step would be showing you how to circuit test everything. I'm thinking I better cut this part short. I'll start a part 2 on putting the rest of the alternator together, and I'll show you the wiring. Thank you for watching. Comment, like or hate, do whatever. I'd really appreciate your input, so let me know. Let me know if I'm doing it right or wrong. This is Prankster Man. I'll catch you later.